Hi, it's time for another math easy solution to discuss further into applications of integrals and look further into moments and centers of mass. Now go over example 3 of the example series and basically solve this example which states find the centroid or the center of mass of the region bounded by the curves y equals cosine of x, y equals 0, and x equals to 0, and x equals to pi over 2. Yeah, now quite simply what this means is, well, we gotta graph this y equals cosine of x function, but this y equals 0, that's just the x-axis. That's whenever y is 0, everything just lies on the x-axis, and this x equals 0 is the y-axis, and this x equals pi over 2 is just a vertical line where x is pi over 2. So let's just draw this out. So the function, let's draw the xy axis like this, x, y, and now the cosine curve looks something like this. So it's going to go from, we're graphing it from, well, 0, that's the y equals 0 line, and then that value of cosine is 1. It goes something like this. Just draw it up to here. So, and recall how the curve looks like for cosine. Just keeps going back up and forward. It's periodic like this. It keeps going up, down and up, and etc. Just keeps going on and on like that. Let's erase that. And this is at the point here. This vertical line is our pi over 2. So basically, we want to graph, and this curve is y equals cosine of x. So the centroid we're trying to find is of this region bounded by the x and y axis, and this point from 0 to pi over 2. And basically, from like I showed in my earlier videos on moment centers of mass, basically the center of this you could tell roughly by the shape, and it would be somewhere around there, I would assume, just something like that. But anyways, now let's try to solve this. And again, this is the center of mass or centroid. See where this is called x and y. These are the coordinates, x and y. Those are the center of mass coordinates. So now let's just recall from my earlier videos the formulas that I used. So recall centers of mass formulas. Formulas in my last video or earlier videos, which I covered, and basically I showed that the center of mass for the x variable, this equals to 1 divided by the area, and in our case the integral is from 0 to pi over 2 of x f of x dx. And for the y coordinate of the center of mass or centroid is 1 over a, the area, and then this is again 0 to pi over 2 in our case. That's the intervals we're integrating from, and then we have this 1/2 and f of x all squared dx like that. And basically where y equals f of x in our case is equal to cosine of x, and the a is equal to the area of the region, which equals to, we just solve it, and that's just the integral from 0 to pi over 2 of f of x dx. So in our case this equals 2, so this area is equal to integral from 0 to pi over 2 of cosine of x dx, and the integral of cosine of x is just, well, sine of x. And then we have to evaluate it from 0 to pi over 2. This equals 2 sine pi over 2 minus sine of 0, and the values for this is, recall the graph for sine of x. This x is y. The graph for sine of x looks something like this. Just goes up and down, etc. And this is y equals sine of x. And at this very top point right here, this is pi over 2. At here is 0 at this point. So at sine of 0 is 0, and this one is 1. So then you could learn more in the video links below on trigonometry and sine function here. So this means this sine of 0 goes to 0, and this goes to 1. So we have this equals to 1, which means basically the area is equal to 1. Yeah, so that makes our calculations easier. So now let's solve for the x-coordinate of the center of mass. This equals to 1 over a, 0 to pi over 2, as I wrote above, x, f of x, dx. So this equals to 1 over a, and 1 over 1, that's just 1, integral from 0 to pi over 2, then we just put this x, and then cosine of x, dx. And now solving this, what we have to do is basically recall the integration by parts, because we have this x and cos x. It's a multiplication of two functions, but then we know that the derivative of x is just 1. So you could simplify that, and whenever you have something like that where it gets simpler, we could use integration by parts. So recall integration by parts, which I showed in my earlier video. You can see that in the video link below for the proof and more detail on it. Integration by parts. So if you recall integration by parts, when you have the integral from u dv of these two functions, this equals to uv minus and then v du. Yeah, so in our case we let basically u, so let u equals 2, and again we have this u goes to du, so let u equals x. So that du is simply dx, so that's just 1, and it's a differential, so add the dx there. And then our dv, that's just equals 2, and again dv, we have to take the integral to get the v, so that's our cos of x dx. And then the integral of this is basically v is equal to sine of x. So yeah, the derivative of sine of x is just cos of x. So what we end up getting is, let's write it here. So now we just add it for the definite integral, the same thing. So 0 to pi over 2 of x cos x dx equals 2. Now, so u times v, so x times sine of x. And then we evaluate from 0 to pi over 2, and then minus the integral from 0 to pi over 2 of v, so v du. So v is sine of x, and then du is dx. So now we have a simpler integral right here that we can solve. So let's just plug this inside. So we had pi over 2 sine pi over 2 minus, then we put the 0 in there, 0 times sine 0. That's just this just goes 0. There's a 0. 0 times that is just all 0. So we have that minus, and now the integral of sine of x, that is just, well, negative cosine of x. Because the derivative of cosine of x is negative sine, so we need to put a negative there to cancel to get sine of x. It's from 0 to pi over 2. Since we have a negative and a negative here, we could just make that a positive. So when we evaluate it. And again, sine of pi over 2, we've already shown above, that's just 1. So this is 1. So this equals 2 pi over 2 times 1, that's just pi over 2. This is 0. So again, this is minus and a minus. We could just take that out, make it a positive. So positive, and then evaluate it all like that. So just make it all positive. So now put the cosine inside. Cosine of pi over 2, and then put 0 cosine of 0. So what we have here, again, let's scroll all the way back up here. So cosine 0, that's just 1. That's the value here is 1, and then up to pi over 2, that's 0. So that's our cosine function. So this is 0, this is 1. So what we end up getting is x value is equal to pi over 2 minus, and this is just 1, so minus 1. So that's the value, and when you plug this into the calculator, so yeah, let's just go to the calculator. You can just use the Google calculator. Yeah, right here, let's just type it in here. So pi over 2 minus 1. This just equals 2. Again, there it is, 0.5707. I'll just round it up to 571. So this roughly equals 2.571, roughly. Yeah, so now let's solve for the y-coordinate of the center of mass, and again the y-coordinate is equal to 1 over a, integral from 0 to pi over 2 of 1/2, then we have this f of x squared dx. Now this equals 2, well a is just 1, so we have this 1 over 2, take that out, 0 to pi over 2, and then this is our cosine, so we have cosine squared dx like that. So in solving this one, well, you could basically use the trig identity first. So recall the half angle trig identity, which I've proved in my earlier video in the video link below. So trig identity, to simplify this because it's a cosine squared, and we could write this in terms of just a cosine. So we have cosine, so cosine squared of x is equal to, this is 1/2 of 1 plus cosine 2x. So this 2x, is double the angle of this one. So this x is half the angle of the 2x, hence the half angle. So we write it like this so that we get rid of this squared. So let's plug that in. We get y center mass in the y coordinate is equal to, so we have this 1/2 and this 1/2, that's 1/4. And then integral from 0 to pi over 2, and then now we have the cosine squared. Write this here, replace it with this cosine 2x, and this 1/2 goes there. So dx, now we could solve this fairly easily. So 1/4, and evaluate this 1 is just x, integral of 1 is x. Integral of cosine 2 of x, that is gonna be sine 2 of x, but then use chain rule, divide by 2. So that's integral and derivative of sine 2 of x is 2 times cosine 2 of x, and then this cancels. So 0 pi over 2. Now what we get, let's evaluate this. 1/4, and then we have this pi over 2 plus sine of pi over 2 times 2, that's just pi, all divided by 2. Minus, put in the 0, 0 plus sine, and then that's a 0. 2 times 0 is 0. And again, I already showed that this is 0, sine of 0 is 0. Now we have sine pi, and we could solve this by going to this function, recall this curve, and at this point is pi, that's again 0. So we have this is equal to 0. So all we end up here is 1/4 times pi over 2. So we get the y coordinate equals 2 pi over 8. And again, solving this using Google Calculator, we get, let's go pi divided by 8. This is 0.3926, or round up to 3. So we end up getting is roughly 0.393. Yes, so basically now the centroid is, so thus centroid of that region is at the coordinate pi over 2 minus 1 and pi over 8. Oh yeah, those are the exact terms, which is roughly equal to, if you use the approximated ones, the rounded up values, this is going to be 0.571 and 0.393. And now let's just try to plot this in our graph initially to see if it's roughly where we just assumed it was going to be. So this is 1, so this height here, again, where this is equal to, this is right here, this is pi over 2 minus 1 and pi over 8. Where this is about just over a third, it would be right here, which is 0.393 is the y direction, and then here this should be over there because this pi over 2 is roughly equal to, let's go pi over 2, 1.571-ish, like that. So this is 1.571. So a third of that is our 0.571. So it's about roughly there. And as you can see, this is about a third of this. So a third, and this is about a third of that, which is pretty much where I guessed where our centroid is going to be. So anyways, that is all for today. Hopefully you'll learn from this pretty useful example on finding a centroid of a shape like this using the formulas of centers of mass or center of mass that I showed in my earlier videos. Anyways, all for today. Hopefully you'll learn. Like always, you could download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.